Alright, today is chapter 10. It's our security concepts chapter. So it's a bit dry being security, but it can be interesting if you've got the correct mindset. A lot of people find security to be either very interesting or very sleep-worthy. Depends on how you take it. Morning, Tate. So basically what we'll be going through is how to mitigate attacks or threats, and be looking at how we can manage to keep track of authorized access to the network, and we'll have a look at some of the layer 2 threats and mitigation around those threats. So we'll start off the day with endpoint security. So basically our end devices, our iPads, our PCs, our laptops, all that sort of stuff. So basically these are very commonly attacked via denial of service, whether it's distributed or straight out. So a lot of these things can occur very easily because a lot of people do not think about security when they're involved in networking, because a lot of people have grown up with the internet and networks always available to them, and having free access with no restrictions has become the norm. But when we start imposing policies to protect the resources, one of the main sticking points is us humans. We're an interesting creation to control, in that we're very much creatures of habit. So when we need to make changes to make things more secure, to protect data, we need to change habits that have not been security minded. So when we talk security, we're looking at the types of attacks or threats that can occur. So from a business perspective, denial of service is very painful and they lose money, which always gets business owners' attention. Next one there is data breach. So this is where information is stolen or compromised, whether it be from servers or host machines. The last one on the list there, malware. I mean, this is all our viruses, our worms, anything that affects the systems adversely, that needs either human interaction, such as viruses, or worms that do not need our interaction, can come under here. So basically this is software modifications, whether it's adding itself to applications or running as a standalone application and adversely affecting the system. So some of the common security aspects we'll be looking at are virtual private networks. So these things are to protect our data while in transit. Okay, so they provide us with a secure connection across a public network into the enterprise, is the most common way. and they normally tie straight into a firewall to provide that extra layer of security. Next generation firewalls are ones that are a little bit smarter, so they actually inspect the traffic as it comes in, and then we get into the intrusion prevention systems where we monitor the network and not only just give an alarm that a pattern of traffic has been determined to be suspicious, it will actually take active steps to stop that pattern from progressing. Whereas intrusion detection systems only will give a warning and no action will be taken by the device. Advanced malware protection and URL filtering, so these things will be active and trying to protect all our systems from known malware, such as viruses and worms and so forth, and sites that are compromised. Network access control, the most common service that has that is AAA. So it handles authentication, authorization, and accounting. So in our larger services, this is where we keep track of who can have access to the network, what they can access, okay, authentication, prove who the user is, authorization, approve their access to the resource, and accounting is keeping a log of what they're up to. More advanced systems like the identification services engine, ICE, is an example that comes under network access control. Now, this is one implementation. There are many others out there. Endpoint protection. Seems pretty simple. What you've got to understand when we deal with security is we have different types of security. Network security only looks at the components of the network. Cyber security looks at everything. Okay, so cyber security looks at both the hardware, the software, and the users, and all the behaviors associated with and around. So there's quite a bit difference between traditional network security and cyber security. Now, people need to be aware of the differences because, yes, network security becomes part of cyber security, but it isn't the all-encompassing thing. Okay, it's part of the solution. So when we look at endpoints, we're talking about anything that connects to our network. And the main reason we're really concerned about endpoint protection and security is because these little funny creatures called humans interact with those endpoints, and we can make some very bad choices in what we do. To give you an example, when I was last in at Telstra, on 2 occasions the enterprise sent out effectively a mock attack against the network, and only about 29-30% of people responded to that threat in an appropriate manner. So what it was is a virus attached to an email. So under the policies was you don't open emails from unknown sources, and you report them as potentially suspicious, and the cybersecurity team would look at the attachments and determine whether it was safe to open or not. So over 2/3 of the organisation made poor choices and clicked on the associated link. Bang, instant link come up saying, thank you, you just compromised our systems. You've just went to a phishing site or whatever, and basically told people that they made a poor choice. So this is why we need to have levels of security and in depth. So when you're talking about securing end devices, it's not just end devices we need to secure, it's the network they connect to as well, because we need to protect the system in depth and have multiple layers of security, because we don't know exactly where threats are going to come from. So by having multiple layers, we help protect everybody from these threats. So traditional host-based security is having an antivirus running on the machine, potential firewalls that are host-based, and even potentially setting up intrusion prevention systems on the hosts. Now, in a large enterprise, that's pretty hard to roll out, and people get upset that things slow down because of those things. So we need to have this multi-layer and not just looking at an end device. So we need to look at our network access controls, our security around protecting our devices, our email security, our web security. So this is where they're coming up with these beautiful new terms, our email security appliance and web security appliances. These are basically dedicated devices constantly looking at the material that flows through the network before it gets to the end devices. Okay, so when we're talking email, it's talking about devices coming through, reading and scanning basically the content to make sure it's in compliance with policies. So email security appliance ESAs are designed to monitor SMTP, and what this allows us to do is block known threats. We can sort of remediate against malware in the initial detection phase. We can discard emails with bad links that are known. We can block access to infected sites so that they do not propagate further. And we can start encrypting outgoing emails, content, to prevent data loss in transit. So how does this work? Well, the system detects and correlates the threats, and by having all these known threats come to a central database, the system can find the patterns and define them, and then put in place mitigation to stop those threats from occurring. So this threat intelligence is updated every 3 to 5 minutes, So it's live and interactive and comprehensive. Basically rinse and repeat with the web security appliance. So again, this is a protection from our web-based traffic. So as you know, everybody loves surfing the web. So this is a major source of headaches and balancing between user access and security. It's always a balancing act. The more security you want, the less performance you gain. So enterprises don't want an overly secure network, because that means they don't have a very responsive network. So a balance between the risk and productivity needs to be achieved, and this is where our security policies come into play, because the corporate needs to define what level of risk we're willing to take. And these are just tools that allow us to achieve that balancing act. So again, same with ESAs, our WSAs are looking at a database. It's blacklisting or denying access to bad websites, filtering what sites are allowed to be accessed via the corporate network. Because remember, a corporate network is not your network, it is the organization's, and it's their policies that are applied. When users are given access, it is a privilege. That is, when we're accessing services that are outside what we need for our jobs. So when we're doing this balancing act, we're looking at all the major sites that we need to access via business, and then we're starting to protect the organization from our employees' surfing habits. Because again, as I said, us humans make poor decisions on a daily basis. So we need to look at the category of websites being visited, whether they're appropriate to be used and accessed via the corporate structure, and then what applications are or scripts are being run from those sites, and whether we should encrypt and decrypt the traffic between those two sources of information. So, access control. We've already covered basic access control by initiating a password on local devices on our switches and routers. So for us to gain access via the line console or the remote lines with VTI, we instigate a password when we go to log in. So that's the first basic level of password protection that we came across. So we're quite used to using username and passwords to log into devices in an enterprise level. And this is where we can apply that same local user database when we start using services such as SSH to get access to our systems. So in this little example on the screen, we've gone through the usual steps of saying, give it an IP domain name, generate our crypto keys. The next line is where we come in to the username and password database. So by repeating this username and password method, multiple times. For each line, we can create a new username and password entry in the local database. And then when we go into the line VTYs, instead of just saying login, we say login local, and that tells the system that it is going to prompt for a username and password and compare it to these username lines within the config. That can be used on any of our lines. So that's our line console, our auxiliary lines, and our VTY lines. Okay, so AAA, I kind of went through this earlier with the authenticate, authorize, and accounting. So I'm not going to go through it again. So where do we want to impose AAA? Well, we can use it locally on each device, and again, we use that local database of usernames and passwords that we can enter with the command structure in config, and we'll send that information out to the local log for what's happening. The other way we can do it is to have it on a server, and when devices are accessed, the device connects to the AAA server and asks for authorization to connect. So these servers are known as radius servers or TACACs, and they provide that authentication. Now, radius is a remote authentication for dialing users, whereas TACACs is a terminal access controller for access to systems. Now, TACACs is normally when we're authorizing devices in the Cisco world. Radius is more multi-purpose, if you like. So, authorization. This is what it just means. It governs whether users can or cannot gain access to the network. In other words, do they have a legitimate account, and can they prove the correct credentials before gaining access to the system? Accounting is basically just a log of everything that user does while they're connected to the system. So the log is generated for every attempt at login onwards. So everything you do gets an entry into the log table, and this will tell us what that user did, the date and time of the action, and the commands used by that user to gain access to whatever resources or whatever they're doing on the system. These logs can be very useful for troubleshooting, and they can be used for prosecution of individuals if they're doing something they shouldn't do. So it's very important when we use AAA that we have synchronized timestamps throughout the network so that everything has the same timestamps, because that's an important part of evidence when we're trying to prove malicious activity, is the when, how, and why. So to provide this level of access control, we might want to use a protocol that is specifically designed to provide authentication. In 802.1x, is this port-based authentication protocol that allows us to check everybody's credentials on a port-by-port basis. So as soon as a device wants to access something, we have a specific protocol that handles the authentication process on our behalf without providing the supplicant, as they are called, the client, access to the full network in the process. So until this authentication process is finished, we do not get access to the full network. It's only the authentication process that is permitted using 802.1x before authentication has occurred. So supplicant, the client, is a device that is running the correct software, and this is both wired or wireless. The authenticator is the switch or the wireless access point that the client is connecting to, and this is the intermediate device that will send for authentication from the authentication server. So the client connects to the switch, and the switch basically challenges them to provide their credentials, and then the switch will send to the server, hey, I have this user, wants to connect to the network, are their credentials actually valid, in a nutshell. Okay, and then when the server comes back and says yes, it's a valid client, and yes, they have valid credentials, you can allow them access. So moving on to layer 2 threats and vulnerabilities. So if we compromise a system at any given layer, we've compromised the entire OSI stack or TCP/IP stack going up. Okay, because if we've got physical access or compromised layer 2 in this example, because we've compromised layer 2, we've also compromised all of the above layers, because we can manipulate the frames to gain access to other things. So that's the problem with exploits. Once we're in, we can force our way into other areas and gain access to systems or data that we should not have access to. Okay, so getting compromised at layer 2 compromises all of your infrastructure. So it's a little bit of a vulnerable position to take. So this is why we need to secure our ports and to secure layers as a whole. So this is why we need multiple layers of defense, because we need to protect all these assets on multiple layers. So in today's environment, we have a lot of BYOD, where we're bringing personal devices into the enterprise. The problem is the enterprise has a policy, and that is quite often different to what you have with your own personal device. So we need to protect the infrastructure from very difficult attacks or threats that are sometimes very hard to detect. Now, this can be very challenging, because remember, from a security perspective, we're basically tasked with fixing every threat, whereas a hacker only has to find one. Once they're in, we've failed in our job. Basically, it's the mentality of management, because they don't understand the vast scope that security needs to protect systems by. They just know they've tasked somebody with the job of protecting things, and they didn't do it. So this is why we have to go about protecting the network in a very documented and structured manner. So just be aware of that. If you decide to go down security, you need to make sure all your I's are dotted and T's are crossed as you go through, because it's very easy for us as a security officer to miss one thing, and that becomes a vulnerability and is likely to be exploited. So we need to be very well educated in all the systems, and it's a very challenging role to take on. Don't get me wrong, it's also a very well paid role. So we are compensated for not having a life and making ourselves available. So what types of attacks can we see at layer 2? MAC table attacks, where we basically get a lot of flooding, a lot of broadcasts that want to change the entries in the MAC table, and what happens is eventually the MAC addresses get full. And what happens once you've got a full table with no matches being available, you start broadcasting or flooding out the traffic out everywhere, and thus propagating the attacks to sources that they would not necessarily be able to get to under normal circumstances. VLAN attacks is where we can double tag or hop between VLANs. So we gain access on one VLAN and manipulate the tagging system to gain access to another VLAN. Now, in theory, this is able to be done. I haven't been around the security crowd for VLANs for a while, but the last conversation I had with a very smart individual that worked for Cisco said in theory it was possible, but he hadn't been able to pull it off yet. And his job was to break things. So he was actually employed after being caught hacking into Cisco. Yes, those stories are valid in real life. So just be aware of that. DHCP attacks are where our legitimate devices cannot get IP addresses, or a device impersonates the DHCP server and gives false information out so that all the traffic starts coming via the same sort of middle attack. So it gets redirected via a false gateway, that sort of activity. ARP spoofing, so basically people impersonating other devices by saying, yes, that's my IP address, this is my MAC address, so send me the frames so I can inspect everything that's going on through the network. So MAC addresses and IP addresses, as they are a logical address, i.e. we implant those addresses into the system. And you're going, no, we don't. MAC addresses are stamped by the vendor. Yes, they're an address that is put into a chip, but guess what? The field can be modified before it's put on the wire. So this is why these can be impersonated and changed, because when we start to transmit these things, they are just ones and zeros in sequence in a specific part of the header, so they can be modified and impersonated. Just be aware of that with the correct software. STP attacks, spanning tree. We went through how spanning tree works, and understanding how a protocol works, we can modify the function of how it elects and governs traffic flow throughout the wireless wired, because it's between switches, system. Okay, so between spanning tree itself, by manipulating the fields and those PDUs, we can manipulate how traffic flows through the switches, and we can have it come up to a device that is compromised, and they gain access to a lot more information by doing that. Because the more information that flows through a compromised system, the more data and information they can collect, the more money or whatever their motivation is can be achieved. So how do we mitigate against all this? Well, we employ port security. So what this does is it limits the traffic, so the MAC address flooding, so having this continuous flood of information coming into one port sort of indicates that there shouldn't be more than one or two devices on there. So by saying how many devices we expect to be attached to a port, we can mitigate the MAC address flooding attacks by saying, no, sorry, you have exceeded the maximum MAC address allocation for the port. We're not accepting any more traffic. Put it into error mode. And the same occurs with DHCP. You're not expecting to have a DHCP server on the port, so we can control what type of traffic flows through that port. So DHCP snooping prevents the spoofing attacks and the starvation attacks, because what we basically tell it is where we expect DHCP servers to occur, and that tells the ports what type of traffic to expect on them. Dynamic ARP inspections prevents ARP spoofing and poisoning attacks, because we know again where the traffic's going to be from, what it should be. And by the last one having the source guards on, we're guarding against the traffic coming from different areas. So that's a lot of information to take in, I know. As I said, networks, there's a lot of moving parts, so there's a lot of areas we need to cover. Now, within our lovely ARP tables and MAC address tables, we have a MAC address recorded against a port number and their associated VLAN for that port. So this is what we're protecting. It's there so that we can switch frames efficiency and with speed. So what happens under the MAC address flooding attacks is we send a lot of fake source MAC addresses towards the switch. It fills up the available memory for that MAC address table, and what happens after that is the default behavior of the switch is that it floods all information out, all ports except for the one it received it on, if it doesn't know where to forward it. So now the attacker has access to more devices than what they had at the start. So mitigation, MAC off. This is a tool, can flood a switch with 8,000 bogus frames per second. Not much, is it? So by having the systems in place to control how much information is allowed in on any given port, we can stop this type of attack from being effective against our devices. We'll look at port security itself in another module, because that is full of different options, and just be aware that we can control what type of information comes into a port, so we can, because we know what our traffic patterns are expected to be, we can put into place elements on the port to limit the traffic from outside of our expectations from impacting the switch. VLAN hopping is where we basically impersonate a trunk, and we can send traffic down VLANs that we shouldn't have access to because we're adjusting the tags and using dynamic trunking protocol vulnerabilities to form that trunk. And if we manage to form a trunk on a access port, which is quite interesting, what we can do is then change VLANs at will and gain access to areas of the network that we shouldn't have access to. Now, we can limit where we can have trunks form, which will help limit what's going on. And as I said, the double tagging type attack is where we're trying to push our way through one VLAN, and when we strip away the header at the other end, we have a secondary header that needs to be actioned and moved on. So remember, native VLANs don't tag, so this can potentially be used to gain access to other VLANs. And the issue is we need to have a method that doesn't allow this sort of behavior. So we need to disable trunks on access ports. We need to disable auto trunking so that the dynamic trunking protocol does not occur. Alright, so one of the ways we can go around this is manually enable our trunks rather than having them dynamic, and make sure native VLANs are only used for trunk lines and not across any other access port. Now, I'm hoping you still remember how DHCP works, in that it sends out a discovery broadcast and gets a unicast offer back, and then it confirms with a request for the specific set that it wants to use and gets an acknowledgement. Now, because it's a broadcast, it can go to other devices that want to impersonate the legitimate DHCP server. So under the spoofing attack, it will send incorrect gateways, DNSs, IP addresses. So it's not part of the legitimate network. It's not connecting to a device, sending it to traffic to incorrect destinations. Can be quite devastating when this takes place. Now, again, ARP requests, it is the function to match an IP address with a MAC address before we can send the frame. So when we get an incorrect ARP reply, we end up sending it out to the wrong device, and this is one of the ways we can get man-in-the-middle attacks occurring, is because the MAC address entry is incorrect and we're sending the frame to the wrong device. And we need to put into place ways of controlling this. So we need ARP spoofing, ARP poisoning, other types of attacks that are frequent with the ARP system, and we use dynamic ARP inspection to mitigate this. I'll let you read all the details in depth, because there's a lot of words on each of these slides and you don't need me to read them to you. So address spoofing is where, as I said, we get incorrect addressing information inserted into these headers, whether it be IP addresses or MAC addresses, and the purpose of this is to send our legitimate traffic to an incorrect location where they can intercept it and manipulate it and then send it on. We protect this by having source guards put on, and this means we limit the ability of them to spoof the addressing, because we know where this traffic should originate, and protect ourselves from impersonations occurring from different sources. Spanning tree is reliant on the bridging protocol data unit to be sent throughout the switched fabric, and we protect this from entering our switches from unknown sources using the PDU guard. We put the guard function on the access port, and if we get a PDU arriving, the port goes into error disabled, and this disables the attack. It does require us to do a manual administrative shutdown on the port and reactivation of the port, so we become very much aware of what's going on and we can track down what's going on. Cisco Discovery Protocol is very powerful, very useful for finding out what our neighbors are, and we want to control this protocol. because we don't want people using this protocol outside of our own network. Okay, so we can turn it on and off globally with the no CDP run command, or we can go into an individual port or interface and turn it off. So we need to control where information can flow. So when we have untrusted devices, in other words, not part of our network, or we can't confirm the legitimacy of the devices, we have to start controlling where we're going to have that information flow. So CDP can be used to exactly find out what the model numbers are of the devices and their IP addresses. Under CDP detail function, we not only get the MAC address and port numbers and device make and model, we can get its IP address. So there's a lot of information that can be obtained using this, and the more information a hacker gets, the more specific attacks they can conduct. And this wraps up our chapter. So what we talked about was securing not only our end devices through antivirus and intrusion preventions and so forth, but looking at where our protocol vulnerabilities are and how we can mitigate those known vulnerabilities by putting in specific control features to limit the chances of those protocols being used to attack us rather than help us with our network. So a couple of new devices, our email security and our web security appliances, a couple of new ones thrown in there that we probably haven't talked about before, but we've talked about everything else before in some form or another. Vulnerabilities of our ARPs, our MAC addresses, our IP addresses, vulnerabilities of our VLANs, our trunking protocols, and how these automated systems can be used by people impersonating the devices or traffic and redirecting legitimate traffic for their own purposes. Again, not going to read line by line, but just be aware that for every protocol that we use, it comes with its own vulnerabilities, and you need to be aware of the ways of mitigating those vulnerabilities to secure your network. And that will bring us to the end of the chapter. I'll stick